Let's begin. Today's September 4th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 10, 13, 18, 19, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our middle digit, the square digit, and compares that value to the number 3. So should square be less than 3? Should it be equal to 3? Or should square be greater than 3? Criteria card B looks at our 3-digit solution and will let us know how many 4s are in the solution. Are there no 4s? Is there a single 4? Perhaps 2? Maybe even all 3 are 4. Criteria card C will look at our middle and last digit, the squared circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D will look at our 3 digits, triangle, square, and circle, and add them up. And the Turing Machine will let us know whether the sum is an even quantity or an odd quantity. Criteria card E looks at our first 2 digits, triangle and square, adds them up, and compares that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will look at the 3-digit solution and tell us a little bit about the structure, so to speak. Specifically, it can tell us whether the solution has a pair of digits, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 6 criteria cards. And we're going to start off with an initial proposal of 314. So I think the first thing I want to find out is a little bit about the sum of the 3 digits. So let's go ahead and test criteria card D. Okay, so the Turing Machine does not approve of my proposal. Since we are adding them up the digits, let's do so. So 3 plus 1 is 4, 4 plus 4 is 8. That is an even quantity, but since the Turing Machine does not agree with it, it's letting us know that actually the sum of the 3 digits should be odd. So let's go ahead and type that up in our notes for section D. And again, that's that triangle plus square plus circle should be an odd quantity. And, just thinking a little bit ahead, there are 2 typically scenarios to consider, and that is that all 3 digits are odd, because the sum of 3 odds does give you an odd quantity, but potentially you could also have 2 of the 3 digits be even, and then if you add an odd to that, then the overall sum remains odd. Okay, so we're either looking at 3 odds or 2 evens and an odd. So the next thing I think I'd like to test is, let's go ahead and see what criteria card F tells us. Okay, so in this case, the Turing Machine does approve of it. So if you notice, our proposal 314 has all unique digits. So that falls under the no pairs scenario. So let's go ahead and type that up in our notes in section F, that the solution has no pairs. And of course what that means is, well, either it's like my proposal 314 where all the digits are distinct, or it could be a single digit repeated 3 times. At this point, I'm trying to see, I don't think we can, even though it's a rare occasion that it's the same digit repeated 3 times, I don't see anything that would disqualify it. Now here's an interesting thought experiment, so to speak. We do have this criteria card B, and as I mentioned, since the solution has no pairs, or actually because the sum total is odd, I mentioned that there could be a scenario where there could be 2 evens. Now obviously there can't be 3 4s. There could be 2 4s, or a single 4, or no 4s. So it may be a bit of a risk, but what I'm thinking is that if there's at least 1 4, I know that the one of the other digits has to be a 2, because remember, one of the scenarios is that if you have 2 evens and an odd, that sum total would be odd. So the risk is, well, either there are no 4s or 2 4s in the potential solution. I don't know if that's a good criteria card. I do like it, but I don't know if it's worth testing right now. Criteria card E is also a good card, and yeah, I'm trying to think. I don't know if it's worth the risk. I think, let me go ahead and test criteria card. Let's do criteria card C and see what we get. Okay, so in this case we are comparing square and circle. Notice that since the Turing machine approves of my proposal, notice that I do have a 1 for square and a 4 for circle. So that means that the Turing machine agrees that square should be less than circle. So let's go ahead and type that up in our notes for section C. And again, that is that square should be less than circle. And let's see, does that reveal anything? Can we cross out anything? Well, if square is to be less than circle, I don't believe square could be a 5, because if square were 5, there's nothing larger for circle to be. And similarly, I don't believe circle could be a 1, because if circle were 1, there isn't anything smaller that square could be. And I think that's all we can actually cross out. Very interesting. Okay, well that does it for this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So obviously we didn't test criteria card A, letting us know a little bit more about the square digit, and we didn't test how many 4s there might be, and we didn't test criteria card E, the sum of the first 2 digits. All very important, criteria cards to test, but those were the choices that were made in round 1. So let's see. So somehow, I do like the variety. Every digit is represented in 1 or more cards. So I do like that. But somehow these 3 cards, the remaining cards that were not tested in round 1, A, B, and E, are what should be guiding us to construct this proposal. So what can we get out of criteria card A? So to help us think about how criteria card C works, and that circle needs to be greater than square, we should be looking at values along kind of this diagonal. So that way, when we do construct it, it's easier to visualize how to pick those values. So what could square be? Obviously, the easiest case would be, it's exactly 3. That may be it. And then, I don't know, maybe there are 2 evens. So could it be that there's a 4, only a single 4 and then a single 2? Could it be something like 4, 3, 2? So we know there's a 4, there has to be another even. If that's 3, then we would be able to pick off if the sum were greater than 6, so that would force us to pick 4. And then, but remember, we got to pick the circle so that it follows this diagonal. Well, it could be, but then it wouldn't be 4, 3, 4, 3, 4. I think that would be too simple. Could it be 2, 3, 4? If the sum is going to be less than 6, therefore forcing us to pick a 2, and then by default circle would be 4. Yeah, maybe. Let's go ahead and try that out. Let's do 2, 3, 4. Okay, so the first thing I think we should probably test, let's go ahead and test criteria card E. Okay, yes, so the sum of the first 2 digits is less than 6. Okay, so that was criteria card E, so let's type that up. So that is that triangle plus square should be less than 6. Okay, so let's see. Can we cross out anything? Let's see. So yeah, 1 could be added to several things that will be less than. So will 2. Well, up to 3. 3 and 2. Yeah, 4 and 1. Yeah, I don't see. I guess the only thing that we can cross out, I think, is triangle. Triangle cannot be a 5, because 5, even adding it to the smallest square digit of 1 is already 6 or greater. Okay, but everything else I think is still in play. Okay, well, that said, let's go ahead and test criteria card A. And okay, so we know this, the square value is not equal to 3. So let's go ahead and cross it out, and let's see what we can come up with. So all we can say is that square is either less than or greater than 3. Okay, so let's see, if square were 4, that would mean the only thing valid would be a 1. But if it's less than 1, 2, yeah, a lot of those do work out. So I don't think we can cross out anything. Only that 3. Okay. And so, well, let's test criteria card B. Maybe, again, if we do have a single 4, we know that there's another even. So let's see, what does B tell us? Okay, so we know there isn't a single 4. So I guess potentially we could still have 0 or 2 4s. And of course, let's not forget, could it also be a triple number? That will be interesting. So let's type up for B that the solution has, we'll say 2 or no 4s. Wow, okay. Well, that again does it for this round. We completed our 3 Turing tests. We've tested each criteria card. Of course, some were, confirmations. Others, we just sort of slightly simplified the options, but I still don't feel very comfortable. Okay. So let's go and think about how to construct a third round proposal. So if we do have 2 4s, obviously, remember we do need an odd. So if either of the first, obviously it can't be 4 4. We know that much because the sum has to be less than. But if there were 2 4s, one of them is a 4, and circle would be a 4. And so it would be something like 1 4 or 4 1 4. Now, is there a way to distinguish between that? 4 1 4. Well, obviously, yeah, criteria card A would be able to tell us which one it should be, 1 4 or 4 1. If there were 2. Yeah, so that's a possibility. And because you're forced to have either if you have 0 4s, well, I don't think it'd be like 2 2s either, because there's really no indication for it. That's interesting. Yeah. Okay, so we do have 4 1 4 and 1 4 4 as possible solutions. What else? Could we be dealing with an all odd? Well, remember, it's either all distinct or all the same. And I don't think it would be 3 4s, because it can't. Well, actually, yeah, it can't be 3 4s. Let's see. Oh, this is interesting. Okay, yeah. So this is a way we can say for sure that there can't be 3 of any one digit. If you have 3 evens, the overall sum is even. So you can knock those 2 out. And then if it was 3 of an odd, that sum would be odd, but notice that for each of the triangle, square, or circle, we have 1 crossed out. We have a 1 crossed out here, so we can't have 3 1s, we can't have 3 3s, and we can't have 3 5s. Okay, so at least we know they're all distinct. Oh, well, of course, no pairs, so you can't have 2 4s or 2 2s. So I think we can safely say then that the 3-digit solution must be all odds. Okay, I wonder if I could have made that conclusion a lot earlier. I think I probably should have. Okay, so I think it's safe to deduce that you don't have any 4s, right? You can't have 2 because there are no pairs. So yeah, solution has no 4s. Very interesting. Why this card? Why did they choose this card above anything else? Very interesting. So it must be that there may be a couple of solutions and one has a single 4, but then you can cross it out because there should be no 4s. That's the only thing I can think of, but so I don't think, I didn't like my single 4, and there can't be 2 4s or even 3 4s. So there has to be no 4s and therefore no evens. Okay, so we're dealing with an all odd. So let's go ahead and do this. Let's cross out all the evens then. So that way we can sort of focus on how best to view the grid. So no 2s here. And no 4. Okay, wow, look at that. So it revealed that square is 1. Okay. Well, that's helpful. Now that we know that there shouldn't be any evens at all. Okay, so let's see. So that revealed that square is 1, which would make triangle 3, which would make circle 5. Wow. That, I don't know where that came from. But that looks like how the solution shaped up. So 3, 1, 5. Okay, so that really felt like it came from left field. So let me just type it up and we'll see if we can confirm, verify what we have and see if it makes sense. Okay, so again here we are deducing that square has to be less than 3. We're deducing because we only eliminate the equal 3. And then we sort of concluded that there are no 4s and there aren't. Okay, so here we go. Making sure 1 is less than 5 for criteria card C. The sum is odd. The sum of the first 2 is less than 6, and there are no pairs. And of course, that means that they're all distinct and no triple digit. Okay, well, I was surprised. I was already thinking we had to go to a third round. Well, let's confirm. We haven't verified it yet, so it sounds good here, but we need the official response. So let's go ahead and type that up as 315. So 315. Okay, wow, I'm a little surprised. I don't know why, but I guess just because it came from left field. We did test each of the 6 criteria cards. And so that's always a good indication of at least tying with the Turing machine and overall beating it. So we did test CDF in the first round, and we got the first and last correct, and then we tested the remaining 3 in the second round, got the last one correct. So CDF, let's do that. So C was correct, D was incorrect, F was correct. In the second round, both A and B were incorrect, and E was correct. All right, so how do we do? Wow, so we beat him by 2 questions. That is a little surprising. All I can say is that, it all kind of came together very fast towards the end. I was not expecting it, and but I think, again, maybe I should have made that conclusion a little bit earlier. Don't know if it would have helped us overall, really, to reduce it, or be able to deduce one of these final criteria cards. Great result. don't get me wrong, but I was very surprised. Yeah, it was very helpful to make that conclusion that, yeah, there should be no evens, and that therefore it's an all odd solution with all unique digits. So this is worthy of a review. And but what do you think? How did you solve it? Did you see anything earlier that could have helped us out? Please add that to the comments. And if you liked it, please do give it a thumbs up, and so that more people can find this channel. And of course, do hit subscribe to be notified so you don't miss out on any future videos. Well, until next time, have a great one.